life applications of quadratic functions, there's definitely real life applications of a reciprocal function. Now, all a reciprocal is, guys, is if I wanted to find the reciprocal of a value or a number, you're basically just writing it, you're expressing it as a fraction, and then you're just exchanging the numerator and the denominator. So if you look at this page on in your packets, and if I said, hey, what's the reciprocal of 3? Yeah, it's just 1/3, okay? So for example, E, the reciprocal of 3/5 is 5/3. Okay, the reciprocal of 2 3/4. So what you do is convert that into a fraction. That's 8, 9, 10, 11. That's 11/4. And then the reciprocal of that would be 4/11. So that's just reciprocals with numbers. Okay, we use those when we divide fractions. When you're dividing fractions, you multiply by the reciprocal. The reciprocal doesn't change the sign either. So, for example, the reciprocal of -2 is still negative, but it's just now 1/2. The sign doesn't change. If it's negative, it's still negative. Okay, that part doesn't change. All right, now on the next part, if I said, what's the reciprocal of these expressions? Okay, well, like 1.5. So what you would do is you would write that first as a fraction. All right, so 1.5 is the same as 3/2. And then its reciprocal would be 2/3. Okay, the reciprocal of x is 1/x. Reciprocal of 2x, 1/2x. The reciprocal of 3/4d, 4d/3. Reciprocal of this last one is x minus 3/x plus 2. It's just flipping. Okay, now when you take a number and you multiply it by its reciprocal, all right, you should always get 1. So for example, if I took 4 and I multiply reciprocal 1/4, I get 1. If I take 2/x and I multiply it by its reciprocal, I'm going to get 1. Right? If I take d and I multiply it by its reciprocal, okay, it's going to equal 1. So the product of a value and its reciprocal is always 1. All right, now what we're going to do is we're going to look at what these functions, how do you graph these functions, and what's some properties about their graphs. Just like we looked at quadratics and looked at properties of parabolas. Okay, the shape of a reciprocal function is a hyperbola. I don't know if you've ever heard of a hyperbola. Okay, a hyperbola is a type of conic section. Okay, your conic sections are a parabola, a circle, an ellipse, and what did I leave off? Circle, ellipse, hyperbola, and parabola. All right, so I'll show you what those look like. A conic section, guys, a section is when you take something and you slice it and you look at the opening. So think of it this way. If I took a stick of butter and I lopped off a piece of it, I cut it, and I looked at the end of the butter, I would see a square. That square is called a cross section. Okay. I didn't show you this yesterday, did I? In this class? Okay. All right. So I don't have it on here. Let me just show you real quick what cross sections are. So I'm going to go conic section animation. All right. So what you're looking at right here is a cone. Now, guys, we all know what a cone looks like, okay? But that's not really a true cone in mathematics. It looks like this. It's actually two cones as soon as my computer catches up here. So a cone is, you would say, well, isn't that like a double cone? No, that's really what a cone is. All right. So a cone actually looks like that. It's two of them. So like those little paper cups that you drink out of, that's half of a cone. This is a full cone. All right, now what a cross section is if I took this full cone and I cut it like with a knife. Now, if I cut it so that it was I cut it like sideways, so it's perpendicular with the top circle and the bottom circle. So I cut it like that. I just lopped this off. Then I turn it and I look at the surface that I created. Okay, what shape is that surface? A circle. So a circle is called a conic section. When you cut a cone this way, you get a circle. Okay, an ellipse is if instead of cutting it parallel to the top and bottom, I cut it at an angle, like this. Now, when I look at the piece that's left over, it's an oval. That's called an ellipse. Okay, so an ellipse is a conic section. Okay, now if I angle it some more, now I'm going to get a hyperbola or a parabola, I'm sorry. So that shape right there, well, that's a parabola. So a parabola is a conic section. Okay, now the way that you get a hyperbola is you just keep increasing this angle until it cuts the bottom.
So that's the name of like the line, or?
The name of these two shapes, you see how you get like two parabolas, but they're in opposite directions?
Yeah.
That is called a hyperbola. Yeah. So you get different conic sections depending on how you cut it. If you cut it like that, you get a circle.
So this is for shapes only, or like when?
Well, I'm just showing you where these terms come from. You know, like what is a conic section? It's just taking a cone and splitting it, cutting it different ways. That's where the conic sections come from. Now you got a parabola right there. There's one there. And now when I take that and I increase the angle and I get two of them, I get a hyperbola. Okay, so this shape where you've got two of them is a hyperbola. Okay, that's what a reciprocal function looks like when you graph it. So when we graph these in a few minutes here, we're going to get shapes. Let's see if you go back to the first page here. Okay, so when I graph a reciprocal function, it's going to look like one of these two graphs for the time being until we get into more involved ones. A reciprocal function looks something like this. Got a curve here and a curve there. Or, so these two curves live in quadrant 1 and quadrant 3. And this is the function f of x. And what makes it a reciprocal function is the variable is in the denominator. K just stands for a number. Okay, so a reciprocal function might look like, it could be 1 over x, it could be 2 over x, okay, it could be 10 over x. Those are all reciprocal functions. And when you graph them, they're going to look like something like this. Okay, and that's what we're going to discover today. So the other way you'll get reciprocal functions is that they'll be in the other two quadrants. They look like this. Okay, so these are also reciprocal functions. The only thing different is this is negative. So if I did negative, and it doesn't matter where the negative is, it can be right out front. These would all be examples of reciprocal functions. So what makes it a reciprocal function is the variable is in the denominator. And so these have all sorts of applications. And as we're going through this, in one of the sections, we do modeling real life situations using reciprocal functions. Okay, one big one is the concentration of a drug in your blood system are measured using reciprocal functions. All right, so if you go now to back to your Google Classroom and click on the link that says 4.1 investigate, and then go ahead and log in. And then just stop where you're at once you get logged in, okay? Parabola, it's a straight line, yeah. If you graph this, it's just going to be a line, and the slope of this line is going to be, it's going to have a slope of 1/12. So if you take a line and you graph its reciprocal, the reciprocal of a line ends up looking like this. That's what the reciprocal is going to look like. So when I just switch those two, and I put the x down on the bottom and the 12 on the top, it now turns into this thing, turns into a hyperbola. Okay, and the way to see that is on your chart here. Okay, so what it says is, fill in the table below with pairs of numbers whose product is -6. Or excuse me, actually we're going to make it 12. Okay, so instead of 6, 12. All right, so for example, what numbers, x times y equals 12. So if x is 1, y has to be 12. These are numbers that make 12 when I multiply them. Okay, 2 times 6. 12. Okay, 3 times 4, 12. Okay, 4 times 3, 12. 6 times 2, 12. Okay, 12 times 1, 12. And if I look over here, you're starting to see the curve. All right, and if I just now -1 times -12, 12. -2 times -6, 12. -3 times -4 is +12, and so on. But just keep, whoops, that one doesn't belong. 3, -2, -1. Okay, so when I look at those, I can see what's starting to look like a rational function. That's all I did was take numbers that multiply by 12. If you click on any one of these dots, you'll notice that the product of the coordinates is 12. X times Y is always 12. Now, what we're going to do is have Desmos come up with the equation for it. Okay, so go down to here now, and it says create a reciprocal model. So remember, for Desmos to draw it, you type in Y1 and a little squiggle, and then K over, and this could be any letter, I just chose K, over X1. Okay, now if you click on that, it fills in the graph for you. So that's what the graph 12 over X looks like. It's a hyperbola. And it's in the first and the second quadrants. Now, what's going to happen to this graph if I want this to be X times Y equals -12? No, I don't. What kind of flip? Right. Is it flipping up and down, or flipping right and left, or it doesn't matter? So if you flip this up and down over the x-axis, okay, would it look the same as flipping it over the y-axis? Yeah, exactly. They're going to look the same. Okay, that's because this is an odd function. All right, and what I mean by that is if I take this piece, remember an odd function, when you turn it upside down, it looks the same. Okay, so if I took that and just pasted it here, and I flipped it upside down, okay, if I take that, oh, I don't know if I can turn this. Okay, so if I flip it over the x-axis, boom. All right, that would be different, okay? Now let me flip it back. Let's flip it back. If I flip it over the y-axis, so flipping it over the x and flipping it over the y create the same graph. This graph and the one I had a second ago are the same. So flip, flip, whoops, flip. Okay, that was what I started with. All right, so this graph here, when we make it a negative, now the two branches are going to be in the second and the third quadrant. And you can see that happening when if you go to the next slide here now. Okay, and now you're going to put in the numbers that make -12. So now we're graphing xy equals -12, or y is -12 over x, which is a reciprocal function. And now we're going to get coordinates in the second quadrant and the fourth quadrant. So fill those in, -3, -2, 1, and then switch them, 12, 6. Don't pack up yet. You got to fill these. Did you fill this in already? Just now. 3. Nope, 3. One of them is going to be positive, one's going to be negative to get this one. And now you can see what happened is now you're getting, okay? And then if we say, hey, put a model together, there's the model for that function. It's just in, so when that is negative, it just flips it. Now, when you look at this model down here, guys, so that you understand what these numbers mean, okay, it tells you what K is. K should be -12, yeah. R squared tells you how good this function fits your dots. When R squared is 1 or -1, that means it's a perfect fit. Okay, so this graph, this reciprocal function here perfectly fits our dots. Okay, all right. The next thing we want to look at, so go to number 3, is to figure out what the domain and the range are of this function. All right, so the domain is the x values. So as I trace this, I'm looking at the x values. What's happening to the x values? Okay, so yeah, bigger, or if I go this way, they get smaller, and then we'll do the rest tomorrow. Have a good day.